Alright, so in this problem, I have x to the power of 6 minus x to the power of 3 is equal to 2. So to solve this, I'm going to first go ahead and subtract 2 on both sides. So now I have x to the power of 6 minus x to the power of 3 minus 2 is equal to 0. Now, x to the power of 6 here, I'm going to rewrite as x to the power of 3 times 2. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 3 times 2 here, I'm going to rewrite as x to the power of 3 to the power of 2. So I have this minus x to the power of 3 minus 2 is equal to 0. And now I'm going to let x to the power of 3 equal to the variable y. So now I have y squared minus y minus 2 is equal to 0. Now we have a simple quadratic equation here. So to solve this, I'm going to rewrite negative y here as negative 2y plus y. So now I'm going to factor by grouping. So if I factor out y from y squared minus 2y and factor out 1 from y minus 2, because 1 is the greatest common factor of y and negative 2. So first off, factor out y, so I have y times y minus 2 plus 1 times y minus 2 is equal to 0. So now if I factor out y minus 2 from here, I get y minus 2 times y plus 1 is equal to 0. So now this gives me two equations. I have y minus 2 is equal to 0, and I have y plus 1 is equal to 0. So for y minus 2 equals 0, y is simply equal to 2, and for y plus 1 equals 0, y is equal to negative 1. Now, recall how we let x to the power of 3 equal to y. So if x to the power of 3 is equal to y, and we have two values of y, well, let's first start with y equals 2. So x to the power of 3 equals 2. I'm going to take the cube root on both sides. Cube root of x to the power of 3 is x, and so we have x is equal to cube root of 2. Now, for negative 1, I have x to the power of 3 is equal to negative 1. I'm going to take the cube root on both sides. Cube root of x to the power of 3 again is x, and the cube root of negative 1 is negative 1. So my two solutions for this are the cube root of 2 and negative 1. So now to check, I'm going to plug these two in. So first, the cube root of 2 So the cube root of 2 to the power of 3, that's simply equal to negative 2. And the cube root of 2 to the power of 6 is 4, so I have 4 minus 2 equals 2, and 2 equals 2, so this is right. And negative 1, I have negative 1 to the power of 6, which is 1, minus negative 1 to the power of 3 is negative 1. 1 minus negative 1 is 2, so I have 2 equals 2, so both solutions are right. Alright, so in this problem, I have 9 to the power of x minus 3 to the power of x is equal to 12. So to solve this, I'm going to first start by rewriting 9 here as 3 squared. So now I have 3 squared to the power of x minus 3 to the power of x is equal to 12. Now I'm going to rewrite 3 to the power of 2 to the power of x as 3 to the power of x to the power of 2. Because if I have something in the form a to the power of m to the power of n, this is also equal to a to the power of n to the power of m. So now I'm going to let 3 to the power of x equal to the variable y. So now if I substitute in y in for 3 to the power of x, I get y squared minus y is equal to 12. Now I'm going to subtract 12 on both sides, so then these two cancel out, and I get y squared minus y minus 12 is equal to 0. So to factor this, we have to find out which two numbers multiply to get negative 12. So a times b is equal to negative 12, and they add to get negative 1. So a plus b is equal to negative 1. Well, negative 4 and 3 work out because negative 4 times 3 is negative 12, and negative 4 plus 3 is negative 1. So now I have y squared minus 4y plus 3y minus 12 is equal to 0. Now if I factor out y from y squared minus 4y, I get y times y minus 4 plus the greatest common factor of 3 minus 12 is 3, so I get 3 times y minus 4 is equal to 0. Now I'm going to factor out y minus 4. So I get y minus 4 times y plus 3 is equal to 0. So this gives me two equations. I have y minus 4 is equal to 0, and I have y plus 3 is equal to 0. So for y minus 4 equals 0, I get y is equal to 4. And for y plus 3 equals 0, I get y is equal to negative 3. So remember how we let 3 to the power of x equal y. So now I have 3 to the power of x is equal to 4, and 3 to the power of x is equal to negative 3. Well, 3 to the power of x equals 4. To solve this, I'm going to take the log on both sides. So then I get x times log 3 is equal to log 4, meaning x is equal to log 4 over log 3. Now for 3 to the power of x equals negative 3, you can't take the power of a positive number and make it negative, so there's no solution for this, and my only solution is log 4 over log 3. Alright, so in this problem, I have x to the power of x to the power of 6 is equal to 144. So I want to find the value of x here. So for my solution, first start with x to the power of x to the power of 6 is equal to 144. And now I'm going to take the power of 6 on both sides. So now I have x to the power of x to the power of 6 to the power of 6 is equal to 144 to the power of 6. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n, right? And a to the power of m times n, well, this is the same thing as a to the power of n times n, because when I'm multiplying two numbers, I can switch the places of them to. It's still the same value. So if a to the power of m to the power of n is equal to a to the power of m times n, and a to the power of m times n is equal to a to the power of n times m, this means that this is the same thing as a to the power of n to the power of m. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of m. So in this case, I have x to the power of x to the power of 6 to the power of 6 is equal to 144 to the power of 6. So we can think of x to the power of 6 here as m and 6 as n. So if I switch the places of these two, I get x to the power of 6 to the power of x to the power of 6 is equal to 144 to the power of 6. So now I'm going to let x to the power of 6 equal to the variable y. So now I have y to the power of y is equal to 144 to the power of 6. And 144, this is the same thing as 12 squared. So now I have y to the power of y is equal to 12 squared to the power of 6. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n, as I already said before. So 12 to the power of 2 to the power of 6, that's going to equal 12 to the power of 2 times 6, which is 12 to the power of 12. And if I have something from a to the power of a is equal to b to the power of v, this means that a is equal to b. So in this case, y is equal to 12. So now remember how we let x to the power of 6 equal y. So this means that x to the power of 6 is equal to 12. So if I take the 6th root on both sides, 6th root of x to the power of 6 is x. So I get x is equal to 6th root of 12.